Okay, hello everyone. There are several slides in order to be able to answer the next set of questions on ions and ionic bonds. Just so it won't be too much, I'm going to split the slides into, we're going to do about 20 to 21 or 2 today, and then 21 or 2 tomorrow. So it'll just be slides on Monday and Tuesday. There won't be a homework assignment on those slides until I'll post those, I think, at 8 o'clock on Wednesday morning. Just reminding everyone, if you're not sure on how to do something, you need to call me. You can call Miss Tommy, and I can come down on the phone and talk to you, or you can email any of us with questions. So we'll get started on ions and ionic bonding. All right, chemical bonds. We learned earlier that atoms are more stable if they have the same number of electrons as an inert atom. The first two rows on the periodic table, the stable number of electrons is either 2 or 10, equaling the number of electrons of the inert elements, helium or neon, in group 18. We can extend that to the third row, in which the elements is argon with 18. There's argon that has 18. Also, we learned that one way an atoms achieve a stable number of electrons is by sharing electrons, and that forms covalent bonds. Once electrons are shared between atoms, the atoms are bound together by covalent bonds. When they're shared, it is covalent bonds, forms a molecule. So far, the elements we studied which form covalent bonds are circled below. So here's hydrogen, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. We extend that on the next page to period 3. Okay, below are circled in purple the 16 elements in the first 3 periods which can form covalent bonds. So they are sharing, these can all share electrons to become more stable. But what about these two, lithium and sodium? They are the only elements which are not identified as being inert, nor being able to make covalent bonds. So what kind of bonds do they make? A big hint would be the title is ions and ionic bonds, so I'm going with probably going to be an ionic bond. Beyond hydrogen, group 1 elements, the far left column, form bonds. If so, what sort of bonds? Let's start by studying lithium. So Li, we're right here. Lithium has 3 electrons. Can you see the easiest way for it to achieve a stable number of electrons? To get to 2, to 10, or to 18? So I would think the closest it's closer to 2 than it is to 10 or 18. So how in the world could we get lithium to have 2 electrons instead of 3? If lithium loses an electron, it would have 2, which is a stable number represented by helium in period 1. Lithium would not become helium since it would still have 3 protons, but it would have the same number of electrons as helium. Since it would have fewer electrons than protons, it would have a positive electric charge. So it is a positive ion. When you lose or gain electrons, you form ionic bonds. Losing an electron transforms lithium from being an atom to being a positive ion. Lithium plus, Li plus. But lithium can't just lose an electron. It has to donate it to another atom. Can you see any atoms below which could use one more electron to reach a stable number? So, okay, we know lithium needs to get rid of 1. Do we see anything here that would need to possibly gain 1? There are 2 atoms shown below that would reach a stable electron configuration by accepting an electron. So this one would take fluorine to 10 and chlorine to 18. Fluorine would go from having 9 to 10, so it would match the same as neon. And chlorine would go from 17 to 18, which would match the configuration of argon. Group 17 elements are called halogens. That's just kind of a FYI there. Fluorine would have 10 electrons and an electron configuration like neon. It would still have 9 protons, so it would still be fluorine. Since it would have more electrons, so more negatives than positives, it becomes a negative ion. So you would write fluorine as F negative. Chlorine would have 18 electrons and the electron configuration like argon. It would still have 17 protons, so it will still be chlorine. Since it would have more electrons than protons, it would become negative, so you'd write that as Cl negative. Group 17, called halogens, remember I just had you star that a slide or two back, strongly attract electrons from other atoms, since any of them can reach the electron configuration 18 by just adding one electron. So let's think about this. So here, this group is probably going to match up pretty well with, say, this group, and this group is probably going to match up pretty well with this one. Group 1 and group 17. These just need one more. Here's the one that they can take from. So this is a very important slide. Everything on this slide is important. Group 1 atoms lose an electron to an atom in group 17. Group 1 elements become stable by losing an electron, giving them the number of electrons of the inner element in the previous period or row. Group 17 elements become more stable by gaining an electron, giving them the number of electrons of the inner element in their period or row. We saw that lithium loses an electron to attain the stable electron number of 2. How would sodium in A attain a stable number of electrons? So if it's, would need 2, 10, or 18. So it gains 8, loses 8, loses 1 electron, gains 1 electron, or I need help. We'll go ahead and let me switch so we can see the answer here. And it would C, lose 1 electron, because it is at 11, so to get to 10, it just needs to lose 1. After donating 1 electron, because remember it just got rid of 1, so it bumps it back to 10, sodium would have the same electron configuration as, so it's going to have the same as, I think it's already circled there for you, which is D, neon. After donating 1 electron, sodium would it be positive, negative, neutral? Let's look and see. It's going to be positive because it's going to now have more protons than it has electrons. I'm just checking my number because I'm just going to split these in half today. And we're getting close to about the number we need to get to today, so we'll go a little bit further. Which of the below atoms would accept a donated electron from either sodium or lithium? And that one would be D, A and B. So chlorine would or fluorine would. After accepting 1 electron, fluorine or chlorine would be positive, negative, or neutral. And it would be negative because now it's going to have more electrons than it has protons. Positive and negative charges attract, repel, neither. And those attract. Positive and negatives attract. 2 positives and 2 negatives would repel. Positive ions and negative ions attract, repel, neither. I think I just was a spoiler on that one. Positive ions and negative ions also attract. Positive and negative attract. Sodium ions would be attracted to what kind of ions? chlorine, fluorine, neon, A or B, or I need help, and it would be D, chlorine and fluorine. Lithium ions would be attracted to what kind of ion? So let's find lithium. Lithium's down here, and it would be attracted to chlorine and fluorine. Chlorine ions would be attracted to lithium, fluorine, sodium, or A and C, and it is A and C, lithium and sodium. Move that down maybe a little so you can see there. I think this will be the last slide for today, but let me double check. Fluorine ions would be attracted to blank, lithium, fluorine, sodium, or A and C, lithium and sodium. Fluorine would be attracted to D, A and C, lithium and sodium. Okay, this is where we're going to stop today, so we're stopping on slide 94. So tomorrow we will cover slides 94 to 112. Remember, call or email with questions. Everyone have a great day.